Section 1.1a-1. We're going to use the approach of Gauss's problem to find the following sums of the arithmetic sequences. For part A, we have 1 plus 2 plus 3 plus 4 all the way to 97. Now, to find the sum of these terms, we want to be able to use Gauss's approach of pairing numbers. Now, let's take a look at this. So if we take a look at this sequence, right? If we add the sum of the first and last term, so if we add this term and the last term, okay, 1 plus 97 is going to give us 98. Okay, and then notice that is the same sum of the second term and the second to the last term. If we take 2 and then add 96, again, it's going to give us 98. Now, notice that this pattern continues for the third term and so on, right? Now, using this idea, Gauss wrote the sequence forwards and backwards and then added the 2. So we're letting S represent the sum of the sequence. So now what we're going to do is now we're going to write it in the backwards. So the sum of the sequence, we're starting with 97 and then going all the way to 1. Now what we're going to do is we have this line underneath there, and what we're going to do is we're going to add. So if we take S plus S, that's going to give us 2S. 97 plus 1 is 98. 96 plus 2 is 98. 95 plus 3 is 98, and so on. Okay, so now what we want to do is the following. Okay, there are a total of 97 terms in the original sum. There are also 97 terms in the sum of 2s, which is equal to the following there. So when you add all these numbers up, you have 97 of them that are 98. So what that means is the following. That's going to leave us with the following equation. You have 2s, which is equal to, now how many sums do we have here? We have 97 of the value of 98. So it's going to equal 97 sums times 98. Okay, and so now what we want to do is we want to be able to solve for S. So that means we're going to take 2S and then multiply 97 times 98, which is going to give us 9,506. Okay, and now we're going to go ahead and divide by 2. So when we divide both sides by 2, therefore S is going to equal 4,753. And therefore, the sum of the sequence is going to equal the following number, 4,753. Okay, now let's go to part B. Okay, part B here is our sequence. We have 1 plus 3 all the way to plus 1,005. Now again, we're going to use Gauss's approach to find a sum. However, in the previous part A, the number of the terms in the sequence was known. For this new sequence, we need to start by determining the number of the terms. So we need to find a pattern relating the last term to the number of terms. So let's take a look at the first two terms. We have 1 plus 3. Okay, so if we have 1 plus 3, the last term is 3, and how many terms there are? There are 2 terms. Okay, the next number is 1 plus 3 plus 5. Okay, what is the last term of that one? It's 5, and then how many terms do we have? 3. We have 1, 2, 3 terms. Likewise, when we go 1 plus 3 plus 5 plus 7, the last term is 7, and the number of terms is 4. And then if we go one more, again, if we go 1 plus 3 plus 5 plus 7 plus 9, the last term is 9, and how many terms do we have? We have 5. Okay? So, now, notice that in each case, adding 1 to the last term gives twice the number of terms. So we're going to represent this relationship in a symbolic form. So what we're going to do is we're going to let n, okay, equal the number of terms okay, and then we're going to let capital L represent the value of the last term. Okay, so what does that give us? That gives us L, which is the last term, which is equal to, excuse me, let me write that again. L plus 1 is going to equal 2n. Okay, so let's take a look at this. If we take a look at the last term, 3, and then we add 1, it gives us 4. Well, 2 times the number of terms gives us 4, right? So let's go ahead and check. So if the last term is 3, and then you add 1, is that going to equal 2 times the number of terms? Well, that checks because 4 equals 4. Okay, let's take a look at the second one. Okay, we know that the last term is 5, and if we add 1, that's going to give us 6. Okay, now remember this is 2 times the number of terms. Well, how many terms do we have? We have 3. And so does 6 equal 6? Yes, it does. Okay, and so on. So therefore, what we want to do now is, since the last term in our sequence is 1005, we're going to substitute that into this equation. So that means that L is equal to 1005. Okay, and then we're going to be able to solve for n by plugging it into that. So plugging it into the formula L plus 1, which is equal to 2n. We know that L is going to equal 1005 plus 1, and that's going to equal 2n. Okay, now let's take 1005 and add 1, which gives us 1006, and that's equal to 2n. Okay, and if we divide both sides by 2, then therefore n is going to equal 503. Now, there are 503 terms in the sum of this sequence. So now, just like we did before, we're going to do the following. Okay, so recall that S was equal to 1 plus 3, and if you remember here, like we did before, okay, if we add the first term with the last term, that gives us 1006. If we add the second term to the second to the last term, again, that's going to give us 2006. I'm sorry, 1006. Okay, so if we write it backwards, you can see that we get 1005 plus 1, 1003 plus 3. And so what does that give us? That gives us the following. That tells us that 2s is equal to 1006 plus 1006 plus 1006. So that tells us how many 1006s do we have. That tells us we have 503 of them. So therefore, in step 3, we can say the following. We can say that 2s is going to equal the number of terms, which is n, times 1006. Well, we found the value of n to be 503. So therefore, 2s is going to equal 503 times 1006. And 503 times 1006 gives us 506,018. And then dividing both sides by 2, therefore S is going to equal 253,009. And so therefore, we would say that the sum of this sequence is 253,009. Okay, now let's take a look at C. So here's a sequence: 4 plus 9 plus 14 plus 19 plus 509. So again, we're going to use Gauss's approach to find a sum. And remember, in part A, the number of the terms in a sequence was already given. But for this new sequence, we're going to start by determining the number of terms. We want to be able to find a pattern relating the last term to the number of terms. Okay, so again, just like the previous step in part B, we have 4 plus 9. The last term is 9. How many terms do we have? We have 2. Next, we have 4 plus 9 plus 14. The last term is 14, and the number of terms are 3. Next, we have 4 plus 9 plus 14 plus 19. The last term is 19, and therefore the number of terms are 4. Okay, and then if we go one more, you will see the last term is 24, and what are the number of terms? There are 5. Okay, so what we want to do is we want to be able to notice that we're adding 1 to the last term gives us 5 times the number of terms. So what that means is, okay, we're going to let n again represent the number of terms. Okay, and then we're going to let L equal the value of the last term. Okay, so what we end up getting is the following. Okay, we know that L plus 1 is going to equal 5 times n. So again, let's check the first one here. Okay, we know that the last term in the first one is 9, and if we add 1, that's going to give us 10. Now, if we take the number 5, we're going to multiply it by 2, which is the number of terms. Right? So again, this is L plus 1, which is equal to 5 times n. Okay, that gives us 10 equals 10. Let's try the next one. What is the last term? The last term is 14. If we add 1, that gives us 15. Now 5 times how many terms are there in a sequence? 3. So therefore we can verify that. Okay. Now, since the last term of the given sum in our problem is 509, we're going to substitute that to be the last term. So let's use our formula. We know that L is equal to 509. Now we want to find the number of terms. So using the formula L plus 1, which is equal to 5n. So we have 509 plus 1, which is equal to 5n. 509 plus 1 gives us 510, and that's equal to 5n. So if we divide both sides by 5, we get the value of n to be 102. Okay, so what does that tell us? That tells us that there are 102 terms in the sum where S is equal to the following sequence. Now we're going to write this sequence as we've done before. So recall here that we have 4 plus 9 plus 14, 499 plus 504 plus 509. And again, remember that 4 plus 509 gives us 513. 9, which is the second term, plus the second to the last term of 504, is also going to give us 513. So, writing this backwards, like we did before, you will see that we have S, which is equal to 509 all the way down to 4. So what does that give us for each value? Well, S plus S is 2S. 509 plus 4 is 513. 504 plus 9 is 513, and so on. So, what does that tell us in step number 3? Well, since there are 102 terms, okay, we know that n is equal to 102. Okay, and we know that the sum of the first and last term is 513. So we're going to do the following. We have 2 times s, which is equal to n times 513. So 2s is going to equal 102 times 513. And so 2s is going to equal 102 times 513, which gives us the value of 52,326. Now to solve for s, we're going to divide both sides by 2, and therefore s is going to equal 26,163. So therefore, we would say that the sum of this sequence is 26,163. Okay, now let's go to the last sequence. We have 872 plus 863 all the way to 8. Okay, so again, we're going to use Gauss's approach to find the sum. This sequence is written in descending order, so we're going to start by writing it in ascending order, and then we're going to determine the number of terms. So we want to find a pattern relating to the last term to the number of terms. So again, if we add 8 plus 17, in this case here you can see what is the difference between 872 and 863, and you will notice that that difference is 9. Okay, the difference between these two numbers is also 9. So that means that 8 plus 9 is 17. So again, what do we notice here? We can see that the last term is 17 and the number of terms are 2. Okay, now if we add 9 to the 17, we get 8 plus 17 plus 26. The last term is 26. The number of terms are 3. Next, 8, 17, 26, 35. The last term is 35. The number of terms are 4. And then last, we can see that the last term is 44 with a number of 5 terms. So again, notice that in each case, we're adding 1 to the last term is going to give us 9 times the number of terms. So again, we're going to let n represent the number of terms. We're going to let L represent the value of the last term. So we end up getting the following. We end up getting L plus 1, which is equal to 9 times n. So again, let's check. Okay, if we take a look at the first one, if we take 17 and add 1, that gives us 18. We're going to take 9 and add the amount of terms there were. That's 18 as well, so that checks. Let's check the second one. If we take the last term of 26 and add 1, that gives us 27. If we take 9 and multiply it by 3 with the number of terms there are, then that gives us 27, so therefore that works. Okay? So now what we want to do is, since the last term of the given sum, written in ascending order, is the following. It is 872. So we know that L is equal to 872, and then we want to find n, which is the number of terms. So we take 872, we add 1, and that's going to give us 9 times n. 872 plus 1 gives us 873, and that's equal to 9n. Divide both sides by 9, and then n is going to equal 97. So therefore, there are 97 terms in this sum here. Now, let's write the sequence as we did before. Okay? So, we know that if we write it in ascending order, we have s, which is equal to 8 all the way up to 72. And then if we write it backwards, we get 872 down to 8. And when we add them together, what do we get? Well, s plus s equals 2s. 8 plus 872 is 880. 17 plus 863 is 880 as well. So in step number 3, okay, again, we know that there are 97 terms in the sum of the first row, s, and there are 97 terms in the sum of the last row. So, since we know that n is equal to 97, okay, we can find s by doing the following. We have 2s, because that's what we get here, and we know it's going to equal the value of n times 880. So 2s is going to equal 97 times 880. So we have 2s, which is equal to 97 times 880, which is 85,360. Divide both sides by 2, and s is going to equal 42,680. And therefore, we would say that the sum of the sequence is 42,680.